JavaScript lets you perform basic mathematical operations like addition, subtraction, multiplication, and division. To make these calculations, we use the symbols and forward slash, which are called operators. You can use the JavaScript console just like a calculator. We've already seen one example, adding together 3 and 4. Let's try something harder. What's 12,345 plus 56,789? 12,345 56,789. 69,134. That's not so easy to work out in your head, but JavaScript calculated it in no time. You can add multiple numbers with multiple plus signs. 22, 33, 44. 99. JavaScript can also do subtraction. 1000 to 17. 983 and multiplication, using an asterisk. 123, 456. 56,088 and division, using a forward slash. 12,345 forward slash 250. 49.38. You can also combine these simple operations to make something more complex, like this. 1,234 57 3 to 31 forward slash 4. 1,397.25. Here it gets a bit tricky, because the result of this calculation, the answer will depend on the order that JavaScript does each operation. In math, the rule is that multiplication and division always take place before addition and subtraction, and JavaScript follows this rule as well. Figure 2 to 1. T. The order of operations: multiplication, division, addition, subtraction. Figure 2 to 1 shows the order JavaScript would follow. T. RST, JavaScript multiplies 57.3 and gets 171. Shown in red. Then it divides 31 forward slash 4 to get 7.75. Shown in blue. NE. XT it adds 1,234 171 to get 8 forward slash 13. 11. That can't be right. You can't give each sibling 11 candies when you've only got 8. The problem is that JavaScript does division before addition, so it divides 8 by 1, which equals 8, and then adds 3 to that, giving you 11. To fix this and make JavaScript do the addition first, we can use parentheses. 8 forward slash 13. 2. That's more like it. 2 candies to each of your siblings. The parentheses force JavaScript to add 1 and 3 before dividing 8 by 4. Try it out. Let's say your friend is trying to use JavaScript to work out how many balloons to buy. She's throwing a party and wants everyone to have 2 balloons to blow up. There were originally 15 people coming, but then she invited 9 more. She tries the following code. 15 9 2. 33, but that doesn't seem right. The problem is that the multiplication is happening before the addition. How did you add parentheses to make sure that JavaScript does the addition first? How many balloons does your friend really need? JavaScript lets you give names to values using variables. You can think of a variable as a box that you can fit one thing in. If you put something else in it, the first thing goes away. To create a new variable, use the keyword var. followed by the name of the variable. A keyword is a word that has special meaning in JavaScript. In this case, when we type var, JavaScript knows that we are about to enter the name of a new variable. For example, here's how you'd make a new variable called nick. Var nick. Undefined, we've created a new variable called nick. The console spits out undefined in response. But this isn't an error. That's just what JavaScript does whenever a command doesn't return a value. What's the return value? Well, for example, when you type 12,345 56,789, the console returns the value 69,134. Creating a variable in JavaScript doesn't return a value, so the interpreter prints undefined. To give the variable a value, use the equal sign. Var age equals 12. Undefined setting a value is called assignment. We are assigning the value 12 to the variable age. Again, undefined is printed, because we're creating another new variable. In the rest of my examples, I won't show the output when it's undefined. The variable age is now in our interpreter and set to the value 12. That means that if you type age on its own, the interpreter will show you its value. Age 12. Cool. The value of the variable isn't set in stone, though they are called variables because they can vary, and if you want to update it, just use equals again. Age equals 13. 13. This time I didn't use the var keyword, because the variable age already exists. You need to use var only when you want to create a variable, not when you want to change the value of a variable. Notice also, because we're not creating a new variable, the value 13 is returned from the assignment and printed on the next line. This slightly more complex example solves the candies problem from earlier, without parentheses. Var number of siblings equals 1, 3. Var number of candies equals 8. Number of candies / number of siblings. First we create a variable called number of siblings and assign it the value of 1, 3. Which JavaScript works out to be 4. Then we create the variable number of candies and assign 8 to it. Finally, we write number of candies / number of siblings. Because number of candies is 8 and number of siblings is 4, JavaScript works out 8 / 4 and gives us 2. Capitalization wrong. The JavaScript interpreter won't know what you mean. For example, if you accidentally use the lowercase c in number of candies, you'd get an error. Number of candies / number of siblings. Reference error. Number of candies is not defined. Unfortunately, JavaScript will only do exactly what you ask it to do. If you misspell a variable name, JavaScript has no idea what you mean, and it will display an error message. Another tricky thing about variable names in JavaScript is that they can't contain spaces, which means they can be difficult to read. I could have named my variable number of candies with no capital letters, which makes it even harder to read because it's not clear where the words end. Is this variable number of candies or number of candies? Without the capital letters, it's hard to tell. One common way to get around this is to start each word with a capital letter as in number of candies. This convention is called camel case because it supposedly looks like the humps on a camel. The standard practice is to have variables start with a lowercase letter, So it's common to capitalize each word except for the first one, like this number of candies. We'll follow this version of the camel case convention throughout this book, but you're free to do whatever you want. Find out how many seconds there are in a year and how many seconds old you are. Let's start by finding the number of seconds in an hour. Seconds in an hour. First we create two new variables called seconds an minute and minutes an hour and make them both 60 because, as we know, there are 60 seconds in a minute and 60 minutes in an hour. Then we create a variable called seconds in an hour and set its value to the result of multiplying seconds in an minute and minutes in an hour. We enter seconds in an hour, which is like saying, tell me the value of seconds in an hour right now. JavaScript then gives you the answer, it's 3600. Bar seconds in an minute equals 60. Bar minutes in an hour equals 60. Bar seconds in an hour equals seconds in an minute, minutes in an hour. Seconds in an hour. 3,600 seconds in a day. Now we create a variable called hours in a day and set it to 24. Next we create the variable seconds in a day and set it equal to seconds in an hour multiplied by hours in a day. When we ask for the value seconds in a day at, we get 86,400, which is the number of seconds in a day. Bar hours in a day equals 24. Bar seconds in a day equals seconds in an hour, hours in a day. Seconds in a day. 86,400. Seconds in a year. Finally, we create the variables days in a year and seconds in a year. The days in a year variable is assigned the value 365. And the variable seconds in a year is assigned the value of seconds in a day multiplied by days in a year. Finally, we ask for the value of seconds in a year, which is 3153600. More than 31 million. Bar days in a year equals 365. Bar seconds in a year equals seconds in a day, days in a year. Seconds in a year. 3153600. 914544000. To figure out your age in seconds, enter the same code, but change the value in age to your age. Or just leave out the age variable altogether and use a number for your age, like this. 29 seconds in a year. 914544000 more than 900 million seconds old. How many seconds old are you? By 1. For example, you might have a variable that counts the number of high fives you received today. Each time someone high fives you, you'd want to increase that variable by 1. Increasing by 1 is called incrementing, and decreasing by 1 is called decrementing. You increment and decrement using the operators and dash. Bar high fives equals 0. High fives. 1. High fives. 2. High fives. 1. When we use the operator, the value of high fives goes up by 1, and when we use the operator, it goes down by 1. You can also put these operators after the variable. This does the same thing, but the value that gets returned is the value before the increment or decrement. High fives equals 0. High fives. 0 high fives. 1 high fives. 2. In this example, we set high fives to 0 again. When we call high fives, The variable is increment, but the value that gets printed is the value before the increment happened. You can see at the end after 2 increments that if we ask for the value of high fives, we get 2. Var x equals 10. X equals x5. X. 15 here, we start out with a variable called x, set to 10. Then, we assign x5 to x. Because x was 10, x5 will be 15. What we're doing here is using the old value of x to work out a new value for x. Therefore, x equals x5 really means add 5 to x. JavaScript gives you an easier way of increasing or decreasing a variable by a certain amount, with the equals and equals operators. For example, if we have a variable x, then x equals 5 is the same as saying x equals x. 5 the equals operator works in the same way, so x equals 9 would be the same as x equals x, 9. Subtract 9 from x. Here's an example using both of these operators to keep track of the score in a video game. Var score equals 10. Score equals 7. 17 score equals 3. 14 in this example, we start with a score of 10 by assigning the value 10 to the variable score. Then we beat a monster, which increases score by 7 using the equals operator. Score equals 7 is the same as score equals score 7. Before we beat the monster, score was 10, and 10 7 is 17, so this operation sets score to 17. After our victory over the monster, we crash into a meteor and score is reduced by 3. Again, score equals 3 is the same as score equals score 3. Because score is 17 at this point, score 3 is 14, and that value gets reassigned to score. Try it out. There are some other operators that are similar to equals and equals. For example, there are equals and / equals. What do you think these do? Give them a try. Var balloons equals 100. Balloons equals 2. What does balloons equals 2 do? Now try this. Var balloons equals 100. Balloons / equals 4. What does balloons / equals 4 do? So far, we've just been working with numbers. Now let's look at another type of data strings.